Today, let's do something that you love. You are good at this. This is what makes you different than many other students. You love to factor, don't you? You love to factor. So, greatest common factor, for example, 2a right here. What's the greatest common factor? It is 2x squared. I take out the 2x squared. I factor it out. I'm left with? Sweet. And you're ready to ace the next test. What is the greatest common factor for letter B?
3y.
3y. Factor that out. You're left with?
3y to the third minus 12y. How did I get that? Oh, wait. I forgot. JK. I got it.
Okay, we just got our first JK in class. Love it. Thank you. We all good?
Yep. No, there should be a 1 in there.
Thank you. That's not correct. It's a plus 1 minus 4y. Okay?
I'm like, go with everything.
So Kendra was throwing some shade there. She was like, Gans, get your act together, because that ain't right, right? Let's admit.
Like, I know it's wrong, but I was like, you're the one writing it on the board, so I'm like, okay.
Right, you know it's wrong, but you're like, he's got a degree in math. He should know what's going on. So you just assume that you did something incorrect, right? So leading you down a path like that, it actually helps learning. It helps you sink it into your brain more. That's what studies show. Now, the other piece I want to show you is, again, that, so like if you live in my family and you come home from a day of math and you have a test, I automatically ask the kids, what was your score on the test? And the first response is, we didn't get it back yet. I'm like, you should know, because you could check every single answer. You can check all your answers, can't you? How could you check to make sure that that's factored correctly? Just multiply it through, right? Yeah, just take 3y, multiply it through, and there you're good to go, right? I mean, that's all we have to do. And so there's all sorts of ways to check your answers. Okay? Excellent mathematicians always find ways to verify that their answers are right, which is why you knew I was wrong. Way to go. Next one, trinomials. You love trinomials. You know that they generally factor to two binomials. X times x is x squared. What are two numbers that multiply at negative 33 but add to negative 8? Negative 11, positive 3. I'm rolling with that. You try the next one on your own. A little bit more challenging. Sure. What even is 48? It's a number that never gets enough attention. That's what it is. Let's see. I got 48 and 1. I've got 24 and 2. I've got 16 and 3. I've got 12 and 4. I've got 8 and 6. Okay, coming up with all the factors. That's part of the number sense that we just want to try to strive our best to have. Some of you guys have better number sense than others. I'm sorry, that's just the way it is. Not much I can do about it at this point. 16 and 3 is what we got, minus 16 plus 3. Flip it over. What's different about letter E and F?
They are, they've got big,
They have coefficients in front instead of 1. So our method doesn't work now. You have two options. We're going to teach both of them to you. Please do not fight them. Please don't get mad at me, okay? I'm trying to help. So the first method would be guess and check. So for example, 8x squared, we would have 8x and x, or you could use 4x and 2x. Okay? So those are options for that front piece. Then 3, we'd have 1 and 3. So if you're guessing and checking, all you can really do is just 8x plus 1 times x plus 3 and see what you get. Now the beautiful thing about this is that you've determined the front's always going to be 8x squared and the back's always going to be 3, right? Like 8x times x is 8x squared, and 1 times 3 is 3. So we've controlled that part. But how do we check to see if we get 10x in the middle? Yeah, you have to distribute the whole thing out or check the inside and the outside. What does the inside give me? 1x, what does the outside give me? Does that add to 10x? No, it doesn't. So it looks like my whole guess and check thing, I didn't guess well. Let's guess again. Somebody got an option for me? Gab is saying, enough with this, Gens, just do the problem. Great. He's got 4x. Did you go plus 3 or plus 1? He went plus 3 here and plus 1 there. Gavin's a good guesser. I'm a bad guesser. 3 times 2x is 6x, and 4x times 1 is 4x. That makes 10x. Now I know that this is factored correctly. Some of you guys are excellent at guessing and checking. Some of you aren't. Can I give you an option to use if sometimes you're struggling with the guess and check option? It is an option called the AC method. Why do we call it AC method? Because ax squared plus bx plus c, we multiply the a and the c together. So 8x squared plus 10x, what do we have, plus 3? Okay, so what's 8 times 3? So we have x squared plus 10x plus 24. So let's focus on that right now. It totally changed the problem, which is everything wrong in math, but we'll get it to work out. Does that factor? To what? Yeah, x plus 6, x plus 4. Y'all good with that? So what's the number that we took off? 8. We got to throw it back on. Are 8 and 6 both divisible by the same number? What?
2.
Divide it out, and you get 4x plus 3. Are 8 and 4 both divisible by the same number? 1. 4. You get 2x plus 1. And there you have it.
What? Can we do that on the next one?
Yes, thank you. That's exactly how I was going to teach it. So let's go to my good friend Sid. She's going to lead us through this. Everybody give Sid a round of applause. Thank you for your efforts. Okay, so AC method, if I multiply the front and the back, I get?
8.
Excellent. X squared plus 7x minus 8. Now I look to see if that factors. Does it factor?
Yeah.
To what?
So x 8.
Good. Plus 8
Yeah.
minus 1. All right, notice how I left some space. What's the number we got rid of that you want to put back in, Sid?
8.
What's the number you got rid of?
2.
Thank you. Good job. And so I just look at the first set. Are they divisible by the same number? What?
2.
So I divide them by 2, I get x plus 4. Are the last 2 divisible by the same number?
No.
So you leave them alone. Okay, I'm hearing some conversations. What's the conversation? I'm hearing, I don't like this. I'm hearing, I like this. Somebody's saying, why didn't we learn this? People say, did we learn this? Okay. So, previous teacher may have taught you this in a little bit different fashion. Some people don't use the AC method ever, and I would probably be there with you most of the time. I'm actually pretty good at guessing and checking, but let me show you a time I definitely use the AC method. And this should hopefully make sense to some of you. Suppose that wasn't a 4, suppose it was a 5. You would sit there and you would try to factor that. You might take a good 5 minutes of trying to factor that, right? Here's what I do when I come up with a problem like that, Mike, and I say, I wonder if it actually factors. I take the 2 times the 5, and I get x squared plus 7x minus 10. Does that factor? Can everybody agree that that definitely does not factor? Does not factor, does it? So if this doesn't factor, then that doesn't either. I know right now people are looking at you saying x minus 2 times x minus 5, but you got to have a positive x. It doesn't matter if you switch these to positive or negative, you're not going to come up with that. So if it doesn't factor AC-wise, if you can tell it right away, then the original's not going to factor either, and that helps you out. Okay. All right, let's try an easier problem other than those difficult trinomials. Difference of 2 squares. Do you remember how difference of 2 squares factors? To what? Three x minus y squared? Oh, good. So you took the square root of 9x squared to get the 3x and the 3x. And you took the square root of y to the fourth to get y squared and y squared. Plus on one, minus on the other. Good. Y plus and minus. Excellent. So we need to understand why. Notice here and here, you get the same thing, right? If you multiply these, just one's positive, one's negative, those would cancel and give you the 0 in the middle. Notice it's a trinomial, it's just there's 0 in the middle. That's why. That way it goes away. You try the next one on your own. Go. I believe in you. Because you're super smart. You like my jokes. Some of them. You can be 13.4. 5. Done, right? What? Oh. Yeah? Oh, you guys are getting so good. I'm so proud of you. You're making this class a lot more fun. The fact is we have x squared plus 1. Good job. Way to go. Now, you know that the sum of two squares does not factor, but the difference of two squares does, correct? So can I just give you just a quick argument of why? Okay, difference of two squares right here. Do you know what the graph of an x squared minus 1 looks like? Do you know what that graph looks like? Parabola. Excellent. And as Sid knows, it's shifted down 1 unit. Can somebody tell me how many times does that cross the x-axis? Twice. So look, it factors to the positive 1 and the negative 1. Now, Sid, what does the x squared plus 1 look like? Excellent. It's another parabola that shifted up 1 unit. Okay? So this one shifted down 1. This is shifted up 1. Does this cross the x-axis?
Yes. No.
No. No factoring. When you can connect a graphical representation with the algebraic, then you're really doing a great job. All right, something everybody remembers, sum and difference of cubes, right? Sum and difference of cubes.
That's like a weird, like something like a formula. It's so yeah.
So let's try to just get rid of all the preconceived notions. Like, I feel bad for sum and difference of cubes. Like, every year it shows up and it knows it's just going to get hated on right away. Okay? So let's be fair to it. Okay? Maybe it's not as bad as what we think. Suppose we had a cubed plus b cubed. You factor it to a binomial and a trinomial. Now, let's see how this is actually pretty straightforward. You take the cubed root of a cubed, which is just a. I should stop doing that. And the cubed root of b cubed, which is b. And if it's plus here, it's plus there. I think the binomial is easy. Can everybody agree? Binomial is pretty straightforward.
Yeah.
Okay, cube root, plus, piece of cake, upside down. What do we do after that? It's not too bad. Watch. Square the front. Hold on. Square the back. B squared. So square the front, square the back. That's easy, right? The middle, multiply them together. This is always positive. This is opposite that. So we'll lead you through it, and you'll be able to kind of develop the pattern. I've seen kids do this before, and you're gonna like it. Suppose this was subtraction here. What would it be here? It would be subtraction as well. What would it be here? Addition, and this is always addition. So let's just use that general reasoning that we talked about, and let's carry this through. Sorry for those of you on YouTube right now. You're wondering, I was writing on the dry erase board. Cubed root of x cubed. X. Cubed root of 8. Plus or minus. We all agree that's a great place to start. All right. Now, here's how I remember it. Square the front. Square the back. Multiply the two together. This is opposite.
Oh yeah.
Not too bad, huh? Try next one on your own. Okay, you should have a 2x and you should have a y squared. Did you start there? Addition or subtraction? Addition, square the front, square the back. Okay, the middle is the 2 multiplied together. 2x y squared. Always positive, opposite. That's that. Yes.
How do you get? So do you split it in two, like the 8?
I identify what do I multiply by itself 3 times to get 8. 2 times 2 times 2. Right? So what do you multiply by itself 3 times to get 8? 2. So that's why the 2 goes there. And then 2 times 4 gives me the 8. So if you were to multiply it out, you'd get exactly that. If it's not connecting, hold the question, and we'll come by right afterwards. Okay, last 2 problems for the day. X to the third plus 5x squared minus x minus 5. Can you factor out an x? No, you can't. But yet people will do this all the time. I tell you the mistakes you can make on the test to try to warn you. You do them anyway. Here's what you do. You go x times x squared plus 5x minus 1. And you put the 5 over here minus 5. You put those together, so you go x times x squared plus 5x minus 6. And then you go x times x. Let's go plus 6 times x minus 1, and you're done. Did everybody agree I did some voodoo math there? Like you just made stuff up? Yeah, I see all sorts of voodoo math on your tests, and I'm trying to keep you from doing voodoo math, okay? It's totally made up. So, yes. So let's group these together and let's understand why. Now, so important. Some of you guys will make the mistake here. Let's be careful with the subtraction sign. Is the value of that 5 positive or negative right now? And if I put a parenthesis like that, okay, is the value of that 5 positive or negative now? It's positive because you distribute that subtraction sign, right? So technically in this situation, how you should write it, and a lot of people don't do this on the test, but you should write it like this, plus 5x squared plus negative x minus 5. Okay? So you should always put a parenthesis down in front of an addition sign, not a subtraction sign, because subtraction changes the values all the way through. Thank you. I appreciate that effect. Now, if we group these 2 sets together, now it's going to make sense. What can you factor out of this? X squared times? Good. What can you factor out of the second set? And you get? Good work. Yo, they're the same thing. So it kind of looks like this. X squared y minus 1y. What's the common factor in that scenario? Y. And so the common factor here is x plus 5. So just like you would take out a y up there, I'll take out the x plus 5 here. You're left with? Am I done? I'm not done. Why? Excellent. Difference of squares. You guys are super smart. Try L on your own. Try L on your own. Go.
Why do you always give us the harder one?
Okay, I have addition signs all the way across, so you go ahead and put the parentheses on. I factor out a 3x cubed. You're left with x plus 2. Then you factor out a 7x. You're left with x plus 2. Notice how I have the x plus 2's? And what remains is 3x cubed plus 7x. Am I done?
No.
Because 3x cubed plus 7x has a factor of? Take it out, and you're left with x plus 2 times 3x squared plus 7. And so that is that. The 2 tougher factoring problems we're not going to go over right now. We will visit N tomorrow. I have your assignment all ready to go. Great job today.
Yeah.